let's take out our computers. We will work for the next few minutes. But how will you share can you share the Dropbox link or the Google Drive links in the group? So he's sharing the Google Drive link where you will see all the lecture notes as well as the files, programming files. Oh yes, they will need the internet, right? Yes. SEIR. Now I am intentionally using the Excel. I know you all have experts in advanced languages like R, like Python, right? But I am intentionally doing this thing in Excel. There's two reasons for that. One is, of course, the conceptual interaction with the terms, how that works. And second is because in industry, people don't use very simple things, they use it in industry. Excel is used almost 80% of the time. 80% of the time. So you should be aware of it. You will say you know Excel, but I would say there is a lot of things to learn in Excel. I'll show you an example. Okay, so everyone got it? Anyone is still trying to get it? If not, try to look into your neighbor's computer if you have somehow not able to get it. So the goal of this is to set up a model, epidemic model. How do you set up? And the second is to simulate that epidemic. So if you see here, there are input model parameters, there are total population size. It's basically doing SEIR, susceptible, exposed, infected, recovered. So that's where it is basically average infectious pre-exposed period, average duration of infectious period, and this is a reproduction numbers, total population size. There is effective contacts, which is leading to beta, and this is infectious rate, and this is recovery rate. And these are initial number of susceptible, initial number of exposed, initial number of infectious, and recovered. So these are all inputs of the model. Okay. Now what is this thing here? Cell names. What are these things? Has anyone know what is cell names are? How many of you have worked on Excel before? Everyone? I'm guessing everyone has worked on Excel. What is cell names? Have you used cell names? Anyone has used cell names? If you have used, you look at this corner here. You look at this corner. Can you see that here? In this corner. This is called cell names. I am naming this cell. This cell is F9 cell as T steps. This is the name of this cell. Okay. And then the cell name of this cell is total population. Now this cell is not named. For example, I am not naming anything here. This is not named. You see that? Only this once I am naming it. And these are the names of the cells basically. I mean, this is for my reference. This is my reference, but this is the names are given right here. You go to the formulas. In the formulas, there is name manager. There is a name manager. If you click that, you can see all the cells that are named by me. All the cells that are named by me. It's one of the efficient way of doing programming in Excel by naming the cell. So these cells are named here, and I'll show you the benefit of naming in few seconds. So this is all the inputs. There is a figure, you don't see anything else, but as soon as you start working on it, you will start seeing the figure going to generate something. So this is susceptible, this is exposed, infectious, and immune is the recovered compartment. Okay. Initial conditions are in yellow, 0 time step, there is the initial, there is everyone, there is 100,000 people, all of them susceptible except one infectious at the time 0. And immune and exposed are 0. How do you compute this? Look at the formula here. It is computing B54, which is this initial value, is discretizing the differential equation basically. And then beta S, this is S at the previous time, this is beta S at a previous time, and then infected number of people at a previous time, beta Si. This is beta Si. And what is beta? What is beta? No, but I have named it. This is the name of the cells is beta. Name of the cell is beta here, right? So this is this thing here, right here. And then this part is for the exposed. It is the number of exposed at the previous time, which is this one, plus how many new cases have been come to the exposed compartment, and how many people recovered, minus how many people recovered. Is that okay? Is it making sense or no? Right? Very simple in this way. And recovered is the same way. Previous time step, how many people were there in infectious, how many new infectious have come from E compartment, and how many have recovered from the I to R. By the way, there is an exposed compartment, so there is no recovery here. This is people going from E compartment to I compartment, basically is this one. Is that okay? It's a discretization basically. So what we do is, this is a model. Now what we do is, now if you see here, it is adding time step. And again, 1 day is a time step. You could have 20 days, you could have monthly, for example, 30 days. So you can define what is the time in which you want to increment your model. So here I am implementing it just 1 day. But time step is right there in the previous. Time step is here. This is time step. Right? This cell is a time step. I could make it 30 days increment rather than 1 day. Okay, so where is the model? So here is the model. So what I will do is, I will run it for, let's say, 100 days. This is 100 days, right? Now, if I click this box here at the corner, I would have all 100 days number of susceptibles. If I click this box, this corner, it will fill up for 100 days. If I click this corner, it will fill up for this 100 days. Is that okay? So this is filled up the number of cases for each of these compartments. And if you look at it, it is now plotting the 100 days curve. For Okay, so if I continue this further and extend this thing for, let's say, actually it is not for 100 days, it is 100 rows, but it is for 45 days only. So let's say if I ran it for 200 days. Let's say 230 days. Look at this curve here. And what happened to the I1? Somehow I messed up the I. Is it what? Okay, somehow it is messed up that I am not seeing the I compartment. So I have to check for it. But you see, it is plotting now the susceptible and recovered for 230 days. Right? It's very simple to work with like this in Excel. I work in an industry called as health economics. All the model we do it in Excel. All of them. Why? Why do we do all the model in Excel? If you go to the industry, there is more likely that you will end up doing Excel. Why do you do in all? I mean, I have done in high performance computing also, but that's not the purpose. Why do we do, people, industry do it in Excel? Can you give me a reasoning? Well, they have money, they can get subscription for anything, literally. So money is not an issue. So what do you think, why do they do it?
Large audience.
What does that mean?
Like people are more familiar with Excel now.
Okay, that's a good point, but who people you are talking about?
People in the industry.
So mostly in industries like big giants, Google, Microsoft, data analysts and data scientists, they work on Excel. So maybe they can share some of their data and they can work and do modeling and prediction studies.
Correct. The reason is partly both of you guys. There is more people know it, Excel. In fact, all of them knows it. So it's a common standard knowledge for across. But not only that, their customer who are not mathematicians, who are maybe in medical fields like clinicians, they don't know programming. At least the level of the programming that we do it on when we do the modeling. So how will they know? They would know things in Excel very well. So to pass on, to share these models with them, they have to do it in Excel. So it is an easy way of sharing the modeling work with other folks. And that's why the industry will always use Excel and will use it for next many years. So you have to be intelligent also, because sometimes when we are in a graduate school, we think, oh, we will do very complex mathematical analysis and we will do a lot of high complex programming, and that's how we'll build my career. That's not the fact. That's a myth. You know what is myth? It's a wrong understanding. Actually, you have to do things, you have to become expert in the things that is sellable. And you know, only 10 to 15% of the people goes in academics, even if you do PhD in mathematics. I mean PhD in that area. Not everyone will become faculty. 10 to 15, that's the statistics I am talking about. So where do other people go? They are not unemployed, they are earning something, they are going in private sector. Right? You understand my point, what I am trying to say? It's very important, relevant features that I am saying. In Excel, there are lots more features that you guys have never heard about. And we do it. Macros, we use macros also here in industry. You know, I was not into Excel until I came to the industry, and then I have to learn it myself. And there's a lot of struggle in that type of. I mean, you ask me to do C++, I used to do things in C++ because it is easy to run on the high performance clusters. It is easy to send the code. not an Excel model will not be very good for that. Now again, having said that, if the model is too complex, in industry by the way, the models are simple, because they don't like complex models. They like simple models that could be understandable, explainable to the clients. So these are the models that we see it, and also you can make it visualizations like as you do it in Power BI and Tableau. They are good for visualization. Excel you can do visualization. And you can share this file easily. You cannot do it in R. Why cannot you share in the R? Why cannot you share in the R? You need a license for R Shiny, hosting of R Shiny app somewhere to share it with someone. That's a lot of challenge, practical challenge in real life. Until unless that other person has a license for R Shiny host, you cannot share it. And same thing with the Python. Again, Python, the issue is people have to know that sophisticated language in order to run that. So there are practical challenges which makes it very limited to go. Okay, now do one thing. Can you count what is this thing? Now the next step is, how do you compute this and this? What is this thing? Newly infectious person. How many newly infectious person is there? It's basically these are the newly infectious. Okay, where is this coming from? How? It is this thing. These are the people coming from E to I. These are the people who are coming from E to I, right? E to I. Those are newly infectious people, which is E to I. Is this only this term? You can see that, right? So this is this thing. What are these newly infected people? How do you compute this? How do you compute this?
Infected of the previous versus the new one.
Correct. From here.
In first case, it will be
This one. Right? It is this one. Now you do this thing. I'm sorry, I copied wrong actually. I copied it this one. So this is this one. So these are the count of newly infected at different time points. And these are newly infected and newly infectious. Those are two different ones. Okay. What is the total population? Is anyone leaking this from this population? No one is leaking out. So this is basically equal to sum of susceptible, infected, exposed, infectious, recovered, which is 100,000, right? And if you see, every row will be 100,000. Come on. Why is it not coming? They are all 100,000. Is that okay? And that is what it is being found. Number of new infectious cases is being plotted. Now open this other file. Now open this other file, which is compare. This other file, if you open, and you have all the formulas that are here. These are all the formulas there in this thing, and calculated this part. This is SEIR model. Same thing, you can do it for SIR model. Same thing. And there is a formula for SIR model. Right? And now here is the second figure in this, which is comparing SEIR with SIR. Recovered compartment look like what? And infectious compartment look like what? So what do you see here? What do you see in this? What do you see the difference in the two models, simulations, SEIR and SIR? What can we learn from it? What are we learning from the difference in the solution of SEIR and SIR? One has an exposed class, one doesn't have an exposed
The
class.
exposed time gives time for the curve to like in the non-SER standalone SER model there is no exposed class. Exposed class of the time is time frame is less. So exposed class is actually increasing the time. That's why the
Yeah. So there is a delay. There is a delay in people getting to an infectious class. Right now, they are holding up people in the E compartment, right? So, and in the E compartment, they are not infecting, right? They are infected but not infecting. That's the definition of E compartment, right? So that is why what you are seeing here in that this delay in the infectious compartment is causing a smaller peak and shifting to the right in the SEIR compartment as compared to the SIR compartment. It's delaying the E compartment is delaying the infection process, and therefore it is lower outbreak and shifted to the right. And that's the important thing. And what you are seeing in the recovered compartment is that SIR people are recovering faster and to a saturating it quicker than in a SEIR compartment. Okay, so this is very important for you guys to think about it. We will do R and MATLAB at some point of time in the course. At least what I will do is I will just share some code with you guys. What we will do now is, this is all we will do it in this simulation, in this one Excel simulation. But what we will do now is we will talk about the projects. And we have, how many minutes we have for, what is the time right now?
8 minutes.
It's 10 minutes almost. We have 10 minutes to the lunch time. So what we want to do is discuss about topics. So anyone has an idea about what they want to work on? And we can discuss and we can think about who wants to work in that. Where is that sheet? Signing in sheet. Okay, group 1. Group A, Vivek, Gopal, Anjali, and I can't read the last name. I mean, eyesight is getting Shubham. I think Shubham. Four people only. In the first one, only 4. Okay, fine. That is fine. We will move around. What do you guys are interested in? What type of problems? I'm asking these 4 folks. Where are these folks? Vivek, Gopal, Anjali, and Shubham. Okay. So you guys are sitting very far from each other. But what do you think? What is your interest? What type of research you? I mean, for example, in the morning he was talking about Aravalli range and like he was all over the place, by the way, but he did showed some interest in environmental related issues. What about you?
So we discussed and
But what is your interest, I'm asking?
so my interest in tumors.
In tumor.
Yes, sir.
Okay. Okay, you want to think about tumor, which is fine also, which is okay. So something to do. So you have to think about what is the challenge about tumor that you want. Because tumor is a big area, right? So, okay, what about Anjali? You are Anjali?
Yes.
So what is your interest? Is tumor is interesting for you? Yeah? Okay, so think about something. Now also it may not be infectious until unless you are talking about HPV. You know what is HPV? No. It's HPV, sorry, I'm saying HPV. It's a virus. It's a virus that leads eventually to one type of cancer. Okay, so that's where the role of HPV. Look at the HPV. That could be infectious process, and it's important thing in the vaccine. So you have to read and think about what are the topics. Who is the other person? Vivek. Where is Vivek? Vivek, what is your interest? Okay, that homework was yesterday. So talking. Okay, so what we will do is after lunch, we will probably sit for half an hour in our group, this group. And we want to know what is few topics. You can have plan A and plan B, right? To think about what would be worthwhile for you all as a consensus. Not that I am interested in doing that. If that is the case, that is also okay. We will look for other people who wants to work in that area, right? We can always move around groups. But we want to finalize the group by afternoon, right? So that we can do some things by the end of the. So we will present also in the last class what we have achieved. I mean, I don't expect everything to be done, but at least you should be having a concrete objective, research objective, and also some model framework, some model equations that we can achieve it definitely. Okay, and we can assign mentors that we can meet it on a long-term basis remotely. Okay, so we'll stop here. What is it's 1 o'clock right now, and we will. How long is the break? 1 hour. So do you guys have to walk back, or where is your lunch? In mess, which is the next building, so not too far. It's far. So that's good in digestion also.
Yeah.
It's always a process.